Hi everyone, it's Liam. I'm going to take you through now the first lesson of year 2 of the exercise physiology unit, and we're going to be looking at energy for exercise. In some respects, this I think is one of the most challenging topics that we cover over the 2 years. Some of you, it'll fall into line straight away. You'll get a deep understanding of it from the outset. Some of you might struggle, and I certainly did when I studied this many years ago when I was at college, when I was your age. But what I can guarantee, at some moment along this process, there will be that eureka moment where it all does fit into place. So stick with it, and as I say, it will make sense as we go through. So what we're going to be looking for in this chapter is this thing called adenosine triphosphate, or ATP. Initially, we're going to see how it's broken down, and then we're going to look at how our body resynthesizes it, depending on what we're doing. So we're going to look at the role of ATP as the currency of the body, the energy currency of the body. It's a very, very key. It plays a very, very key role in as able to beat a heart and be able to run around playing sports. We're going to look at how it's resynthesized once it's been broken down, and we do that through 3 pathways: the lactic acid, and the aerobic pathway, or the ATP-PC glycolytic. Them words are used interchangeably. Now, from GCSE, you will have just studied aerobic and anaerobic respiration. At A level, we actually split that anaerobic respiration into those first two, the ATP-PC and the glycolytic system. And then once we've got an understanding of the systems, we moved on to something called the energy continuum. And the energy continuum looks at how different sports rely on those pathways in different ways, or indeed in some sports, how you may suddenly go from one pathway to the other, depending on what you're actually doing within that sport. For the rest of this session, we're going to be looking at the role of ATP and how we break it down. And then we're going to look at this process, these terms: coupled reaction, exothermic and endothermic reaction. So we need to have an understanding of that when we finish this lesson. The key terms of the chapter are listed there. Now, these are all in the book, in the green boxes that they have in the book, the key term roles. Now, don't go and look at them yet, because hopefully we'll explain them as we go through. These are terms, if we're being asked questions on ATP and resynthesis, these are kind of words we need to be getting into our exam answers. Right, for now, what I'd like to do is grab a sheet of paper, draw a 2-column table, and then in the left-hand column, you're going to say, what do I know now? And I'd like to answer these questions that I've put on there, just to see what understanding we've got at the start of this lesson, because I know some of you will have a good understanding, some of you maybe less so, and then we're going to see how that changes at the end. So what I'd like to do now is pause this lesson, answer these questions, and when you're ready, hit play and we will carry on. Okay, so now you're back. We're going to go through what is ATP, so hopefully we get an understanding of going here. So ATP, if you get any exam question on this, it is the only usable source of energy in the body. So it's very, very key we write that down. So if you get a question on ATP, make sure we put that down before we start saying anything. So the only usable source of energy in the body. We'll see a little bit later when you eat pastas and Lucozade Sports and things like that. Yes, that does give you energy, but actually the energy for exercise comes from this term ATP, and we call it the body's energy currency. Food sources then. So when you have your pre-match meal, so in the chapter last year when we looked at ergogenic age, one of the things we looked at was pre-match meals and taking on complex carbohydrates and low glycemic index foods. Yes, they are very, very helpful to give us energy for the activity, but rather than actually breaking down the pasta to provide energy for sport, we break down the pasta that enables us to make this ATP, that enables us then to break that down to do sport. In our body, though, we've only got 2 seconds worth of ATP, so we only actually store 2 seconds worth of energy, and after 2 seconds, we enter, I suppose, a state of exhaustion, and then we need to lean on those 3 pathways that we mentioned earlier in order to get this adenosine triphosphate put together. And this is kind of how it works. So adenosine triphosphate is an adenosine molecule, and then the triphosphate, tri meaning 3 and phosphate meaning phosphate. So it's an adenosine molecule with 3 phosphate molecules attached to it. Now, the terminal phosphate, so the phosphate on the end, this has what's called an unstable bond, and the bonds between the phosphates are what's called high energy, so they contain lots of energy. Now, when an enzyme called ATPase comes along, an ATPase enables us to break this bond between the second and third phosphate. What that results in is energy being released. We can see down here the energy gets released, and then it leaves us with adenosine diphosphate, di meaning 2, so it's an adenosine molecule and 2 phosphate molecules, and then there's what's called a free phosphate. So ATP is broken down into ADP plus P plus energy. And the energy we've got down here is actually used for sort of metabolic processes, so like contracting a muscle and things like that. Okay, so the enzyme that breaks it down, it's very key we get this, is known as the easiest enzyme we know is ATPase, adenosine triphosphatase. And as ever with enzymes, have the suffix of ase. So if you see that, you would tend to be talking about an enzyme. And whenever we're writing enzymes, and we'll see some more with the aerobic and the anaerobic systems that we cover, always make sure after the letters that you put there, stick A's at the end of it so people know exactly what you're talking about. What the breakdown of ATP does, though, is when ATPase comes along and it breaks that terminal bond, it converts potential energy into kinetic energy. So kinetic energy is kind of moving energy, and that's called an exothermic reaction. So an exothermic reaction is when energy leaves an area. So we've got this bond that's tightly packed. Because energy goes away, the heat goes away, that is called an exothermic reaction, and leaves us with this ADP plus P plus free energy, and that's also worth putting in your exam question. The process, though, is reversible. So what we can do, so here we've got ADP and some P. What we can actually do through other processes is take that P and add it back onto the ADP, leaving us with ATP. And that would be through an endothermic reaction. So we take energy from elsewhere and we put it back on. And where the energy comes from elsewhere is the foodstuffs that we're eating that allows us to put that back together. Okay, that will be an endothermic reaction, and that process is called a coupled reaction, where we would take energy from a foodstuff being broken down, and then we use that energy for another concepts going on there. So here, what we've got is in diagram format. I prefer diagrams, and I'm talking, there's words up there, so I do prefer the diagrams. You can see the ATP, so the adenosine, the 3-phosphates. When the terminal phosphate's broken off, this energy, and if you're writing this down, I will put from the energy maybe an arrow to say that this energy is used for muscular contraction. So for us to run, to come out of the starting blocks, to kick the football. And then at the bottom, what we can see is when that process has happened, we're left with an adenosine diphosphate plus a free phosphate. So that phosphate hasn't been destroyed, it's just been removed from what we've got here. And if we write that out as, I suppose, an equation, is ATP with ATPase affecting it, leads to ADP plus energy plus P. Okay, and this process here we've got as a coupled reaction. We can see, I suppose, the life cycle of ATP. So we've got ATP at the top. When we want to contract the muscles, so take your mark, set, go. On the go, we need to contract our muscle to leave those blocks. Or on the buzzer for a swimmer, they need to dive off the blocks. If it's a footballer kicking a football, when we need that muscular contraction, what we do is we break the ATP down into ADP. Okay, so the energy here that's been released has gone off to contract the muscle. Now, as it comes back the other side, we can see here, and again, if you're drawing this, energy from food, this energy here has come from when we've broken down carbohydrates, broken down fats, we may have broken down protein, phosphocreatine that you remember from the structure of the different muscle fibers, we can break down that. That energy is actually brought in, so we can convert the ADP, and the P back into ATP. Okay, so the coupled reaction, the term we use for that is energy from one process, so from breaking down that carbohydrate, is supplied to form another process, turning ADP back into ATP. Okay, so what I'd like to do now, again, is pause this video, and then I'd like you to then write down what you now know. So in that 5-minute summary now, can we now answer these questions for what's going on? So pause it for a couple of minutes, write that down, and when you're ready, hit go. Right, just to quickly check your answers on that. So what is ATP? It's adenosine triphosphate. It's the only usable source of energy in the body. What is the role of ATP? It's to be broken down in order to provide energy for muscular contraction. And if you do biology, we'll see it's got many different, basically every time we need energy in the body, ATP, it comes from ATP. So, but from a PE perspective, we're looking at that muscular contraction. How is it broken down? We'll remember that adenosine triphosphatase, ATPase, is the enzyme that breaks that terminal phosphate off to form ADP. And then that answers the next question. What is it broken down into? It's broken down into adenosine diphosphate plus energy plus a free phosphate. How much is stored in the muscle? Remember, we said there's 2 seconds before we need to start putting it back together. But after that 2 seconds, because we start to put it back together, we kind of got an endless supply of energy. And then the types of endothermic and exothermic reaction. Remember, exothermic is a reaction that gives off heat or energy, and an endothermic reaction is a reaction that absorbs or takes in heat. So it takes energy from somewhere else and it brings it in, and we do something else with it. Okay. Okay, now I'd like us to look at some exam questions. These are both questions that have been on previous exam papers. Now, question C, the one at the bottom, I've taken out the first part because we've not studied that bit yet. And they explain the role of ATP in providing the energy for muscular contraction. That would actually be 3 or 4 marks of part of that question. So try and do that as a 3 or 4 mark question. So once again, hit pause, and when you're ready to recommend, we'll go through the answer to this. Press play, and we'll carry on. Right, with the questions, you can see at the top of the page, we're not going to put on the mark scheme. So again, pause the recording, and then you'll be able to check your answers against that. And here's the second part of the question. Once again, pause the recording, and then you can see whether your answer will get that. We see that's a sub-max of 3, so maybe, but you can put, if you've got up to 7 marks in that question, see how you've got. So that now brings us to the end of this lesson. So remember, the objectives for this was to get you to understand the role of ATP, how it's broken down, the process of the coupled reaction, putting it back together, the exothermic and endothermic reaction. Now, if you've not understood anything, obviously you can go back through this. You can get in the textbook and look at the first few sections of chapter 1.1 in the year 2 textbook. And also you can head over to the Everlearner, where James on there has got a lesson on this as well, so a little bit more like hands-on writing, so you follow it a little bit better on his screen. So I hope you've got an understanding of that, and we'll see you again soon.